Welcome back again. Today we would like to talk about the idea of a p-value. A p-value I find is one of the most commonly misunderstood terms in all of statistics, and I think spending a moment to think about it will make it much more clear to you what you are doing when you perform a hypothesis test. So first let's take a second and look at the definition of a p-value, which I'm sure you have heard by now. A p-value we can think of in two ways. One, it is a numerical measurement of how strong or how significant your evidence is. So if you go gather some evidence, it tells you how strongly that evidence supports some conclusion, and we'll talk a little more about that later. Second way, which is a little more technical, is that a p-value is the probability of observing the evidence or the data you have if the null hypothesis is true. Now let's think about this a bit differently for a little bit. Let's suppose you are sitting on a jury and someone is on trial, and here in the US we assume that this person is innocent until proven guilty. And what will happen when you are on the jury is that the lawyers are going to try to present some information, some evidence, to help you decide if this person is innocent, the null hypothesis, or the alternative, that they are not innocent, or should we say guilty of the crime. Now what we are going to do is sit here, and you would sit and hear the case, and throughout the case the lawyers are going to present a large amount of evidence to help try to convince you that the person is guilty. Now, if it's any sort of interesting case, most likely the evidence will not tell you 100% that they are guilty or 100% that they are not guilty. So what we need to do is get a measurement that helps us determine, do we think they're guilty or do we think they're not? And a p-value is exactly that measurement. So a p-value we can think of as, again, coming from this definition, the probability of observing the evidence you have if the null hypothesis is true. In other words, it's the probability that you would go out and observe all of this evidence the lawyers brought before you if the person was in fact innocent. Now, in most trials, that evidence will be pretty strong. So you may get a p-value that looks like something like 0.013. And what that tells us is that there is a 1.3% chance you would observe the evidence if they were innocent. And in statistics, that would be if the null hypothesis was true. And in this case, if you got a p-value of 0.013, that seems very unlikely that you would have all of this evidence if the person was in fact not guilty, if they were innocent. And since it seems so unlikely that an innocent person would have all this evidence against them, we would go ahead and conclude, or likely conclude, that this is strong evidence that they are guilty. On the other hand, you may see all of this evidence, and at the end, you may get, and forgive me, but I can't erase this neatly. You may observe all this evidence, and you may get a p-value that is something like maybe 0.23. Now, in this case, we would say there is a 23% chance of observing this evidence if they were innocent. In other words, for 23 out of 100 innocent strangers walking on the street, 23 of them may have evidence this strong just by chance. And hence we would give it a 0.23. In this case, we would say that's pretty likely that some random person would have all this evidence against them. So we would not want to say they were guilty. We would want to go ahead and say we have very weak evidence against them, so we're going to go ahead and conclude that they are not guilty. So, the one question that we have is, where is the cutoff? When do I decide something is strong evidence, and where do I cut off and say that it is weak evidence? And for that, we need a significance level.